You look at marks of a particular student. Student A got 57 on Christmas and 66 marks over summer. And then you have all these marks by B, C, D, E, F, G. So, first question, calculate X bar, Y bar. Please don't use don't use hand to calculate 57 plus 35, blah, 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 blah. You know you're going to enter all these into L1, L2. L1, L2, you can actually calculate X bar, Y bar. Alright? So by GC, you should be able to calculate. Alright? I'll give you all some time. If you all can enter, then you can see the context better. Okay? I also enter. Shall we? Just spend a little bit of time to just enter them. Alright, we can enter them. Pause this better. You can actually do calculate two variable stats, L1, L2. Immediately you can get our X bar, Y bar. Alright? Yes? Alright, let's go back to this one, X bar, you just Y. X bar and Y bar. You have attention, please. Sketch the above data and plot X bar, Y bar. Now, this is printed for all of us. Take notes, because this is printed for you. When you sketch it, you must include a very important things. Your axis, your scale, and then the points must be, have attention please. The points must be all relative to each other on your GC must copy over. When this is this X, Y coordinate is higher, means it must be higher. You know what I'm saying? So ignore the red dot. They must be all relative to each other, just like on the GC. Just like on your GC. So part 2 is done for you. Part 3. Find the estimated regression line of Y on X and draw this line on the graph. Now, is the graph drawn for you? Yes, yes or no? Yes. Oh, so good. I'm so kind. Okay, so what you do, never mind, let's do this. Calculate this one, L1, L2, yes, then you put on into L1, alpha 1, enter. Alright, what you should do is to really go to stat plot, turn it on, then you go to zoom 9. Oh, sorry, this the Y2 must cancel away. Alright, then you can see this one relative to everything. So sketch for you, no problem. I want to stress this. X bar, Y bar must lie on both the regression line of X on Y and Y on X. So, this one not done for you, right? This one must lie on the regression line of Y, X. Okay? If you have time, really go to a GC and make sure that you can get this regression line, this equation out. Is that all right, Ken? Then you will also label your 15.8 and 0.7. The most important point about this example is that when you sketch your regression line, this point, which was originally there, must lie on the regression line. Okay, I said earlier, X bar, Y bar must lie on the regression. Most important. All good? Yes? Good? Example 10. Example 10. Let's take a look at this. The age is x, the height is y. Calculate the linear correlation coefficient between x and y and comment upon the result. Now, this is printed for you. I think quite easy. I don't think it's necessary for me to let you copy. But can I have a small tip for all of us? When you enter into your GC, I suggest you write down on your question paper L1, L2, which what you enter. That means if you really enter all these values in L1, then you just put this as L1, L2. So that later on, have attention please. Later on, you want to do X on Y, Y on X, you know exactly what you enter. You know what I'm saying? Yes? Write it down. Write this down on your question paper. Write this on your question paper so that you know what you enter into L1, L2. Okay? Yes? So I think that's done. By GC, you will get 0.903. You say that there could be a strong linear correlation coefficient, strong, positive, linear. So the three words are important. Strong, positive, linear. By GC, you will get a regression line. I think that's fine. Next, the question asks us to use this regression line to estimate the height 9-year-old. Now, X is the height, X is the age. You want to estimate somewhere at 9 years old here. What is the value of what is the height? Correct? Yes? You need to comment on the value. Now, what do we think? We already know what is this is age, right? This is height, right? I don't think it's difficult to tell me that when X is 9.0, what is Y? Since I already have your regression line. But I will use 5SF 87.431 plus 4.4617 times 9.0. By GC, I will get 128. So that means the height of the 9-year-old now, you substitute 9, is 128 cm. But that's not all. The question asks you to comment on the reliability. I don't know whether you remember the earlier example. We said it was not reliable because it was extrapolation. But this case is not extrapolation because it is intrapolation. It is within range. But the next thing we're going to consider is, to begin with, the data that you collect, is there a strong positive linear correlation? Yes, because they really lie close to a straight line. So you must also mention the value of R, since they already asked you to calculate the value of R. So you will say, since R equals to 0.903 is close to 1. That's the first reason that is actually a strong positive linear correlation to begin with. And you are doing interpolation. X equals to 9.0 lies within the range 6.6 to, you collected data from 6.5 years, 6.6 years old to 13.5. The estimate Y equals 128 is reliable. Next, the question asks, State the value of y given by the regression line when x equals to 40. Yeah. Next part. When the guy is 40 years old, y. Comment upon the answer. So we calculate first and then we comment on the answer. Calculate is not difficult. I don't think it's really difficult to calculate the value. So I'm just going to quickly show you the answer. Alright, you calculate, you substitute 40 in, you'll get 266. Remember, 266 is the height. Is the height. Obviously, by logic, you will say, obviously not reliable. But what's the reason? 266 cm is not reliable. Why? It is out of range. Extrapolation. Yes? It is out of the range, it's extrapolation, it is not reliable. Yes, it's not reliable because it's out of range. And I think I specifically use this ridiculous example to drive home the point that we only collected data from 6 and 6.6 years old to 30.5. You cannot estimate someone who is 40 years old because it's extrapolation. It's ridiculous. Right? It's ridiculous. 266. Now, it's the last part that I want to say a bit more. Okay, Ken? Can I show the question for last part? State with a reason. That's where it is, let's start this. Whether it is appropriate to use y on x to calculate and estimate for the average age with height. Oh, oops, sorry. So now you are given y equals to 150. I want to find out what is x equals to what. Have attention, please. You have found the regression line of y on x. You want to find the average. What is the value of x when y equals 150? The clear-cut question you ask yourself is this: when I plotted y on x, when I have the regression line of y on x, is there a clear-cut independent variable? If there is clear-cut independent variable, which is your a, which is x, that's okay. Then you can use this. Correct? If there is clear-cut independent variable, the independent variable always be on the horizontal axis, regardless. But if there isn't, then to estimate x, given a specific y value, you cannot use y on x. You must use x on y. Got it? Got it? So the question we will answer is, when we talk about age and height, there wasn't a clear-cut. Was there a clear-cut independent or control variable? Actually, there wasn't. There really wasn't. When we collected data, we just say a boy 6.6 years old is a pair of values. We collected it like that. We actually did not control any variable. We actually did not have any independent variable. And when we set it up like that, you look at the phrasing of the question. We didn't even control anything. We just say there are how many boys? 10 boys, just like that. There's no independent or control variable. So the answer is we shouldn't, if we want to estimate the value of x given a particular value of y, we should use x. It's not appropriate. Can get this idea? So everyone all right? Oh, there is no clear-cut independent variable in the phrasing of the question.